Hey, and how's it going, everybody? Thanks for watching my video again. And this time I'm gonna build a voltage regulator. This is how it's gonna look. And it goes up to around 13 volts, so it's not that much, but for an amateur, it's pretty good, I would say. And it's handy for running small appliances, like you can test little light bulbs with it and other things. So yeah, let's have it a try and try it out. Here's the video how I put it together. Thank you for watching, and don't forget, hit that subscribe button so you don't ever miss another video that's coming out. I got lots of projects on the go. Thanks. Kit came very well packaged and had a little less components than my previous build. But the operator's manual had very little to no explanations. The only useful part of it was the circuit drawing. It also had a hash code that my phone would not catch up on. After sorting through the components again, I realized that at least the mainboard had very well labeling. With that and the circuit drawings of the manual, I was set, and started to install the MOSFET transistor to the heatsink. These are used for kits that run high voltages. A heatsink is made out of metal, in this case aluminum, because metal conducts heat way better than air does. It is also worth mentioning that you would need a screwdriver for a lot of the components in this kit. With the MOSFET transistor in place, it was time to keep going with the rest of the resistors and transistors. All were double checked for their values with my multimeter, and the board had clear markings in which direction to point the positive and negative leads of the transistor. I then cut all the leads flush again before moving on to the next step. And this is where I made a small mistake by forgetting to install the smaller two capacitors right away, and instead moved right to soldering the socket for the integrated circuit in place, which is also known as IC. ICs are very insensitive to heat, that's why it is best to solder just the socket in place first. Then, with some help of the circuit drawing, I installed the electrolytic capacitors, making sure the positive and negative leads were going into the right direction again.
Chasing every starlit dream, falling in the ocean of your arms. There is nothing we can't be.
I then soldered the small speaker to the board, making sure the positive went the right way. That's when I finally noticed that I missed the two small ceramic capacitors that I mentioned earlier. Now it would be way harder to get these into place with all the bigger components around. If you plan on building one of these kits, I would recommend to solder these right away with your resistors, so you don't have to struggle getting them into place like me after. With a bit of some deserved struggling, I finally got the two small ceramic capacitors in place and moved on to the small transistor. There was only one of these in the kit, and it was soldered on in no time. The same thing went for the variable resistor, which also was very quickly installed and will later be used to increase or decrease your max current flow. Then came two mid-size electrolytic capacitors, which also needed to be checked for their polarity. The two screw terminals were pretty easy to install, and I really liked soldering this kit so far, for its simple mainboard and all the markings it had. The 3-digit display came as next part, and I must mention that I could have cut the lead wires way shorter, but I didn't think of it at the time. It would have saved me a lot of room in the box. But I'm still learning and have never done this before. The 3-digit display was meant to be held in place by little nuts and bolts. Then I continued to install the 4 LEDs with their poles pointing into the right direction. And the board really started looking better.
There is nothing we can't be. Even though the freedom of this love, and we crash in the wake of the sunset. Every dream comes alive in your heartbeat. We are lost in the waves of the
Then I pushed the IC into place, making sure the little legs of the IC would not bend or break off. I also made sure that the poles were right again, with the semicircle facing to the top. Then something else happened and my camera died. I only realized it after the DAS switch was already soldered on. But that was pretty easy to install with only 3 pins. I don't think I must explain much more. And I'm going straight to the transformer, on which the end with the 2 blue cables should be soldered to the main board and the end with the 2 red cables to your power supply cord. And yes, this kit actually came with the power cord. But before installing the cord, I decided to solder the red and black prongs first. Little tip on the side, if you use a screwdriver the clips won't tip over so easily and it makes for better soldering. I also folded the wire around the clip for better contact. With both ends done and the rubber housing pulled back over the clips, I decided to now remove the protective paper from the acrylic casing of the voltage regulator. And I will not explain much on how to put together the housing. It was very straightforward and you can for the most part just watch it come together. With the main circuit board and the transformer now secured to the bottom of the housing, it was a good idea to solder the power cord to the red wire ends of the transformer. I soldered the red wire to the side where it said 110 volts and the black to the side where it said 12 volts on the transformer. And then heated up the shrink wrap to hide my beginner's soldering job.
chasing every starlit dream.
On the other side, the alligator clips were next. They just needed to be wedged into the screw terminals and the screws tightened after. The one thing I will mention about the housing though is that it was easier to install the washer and nut for the switch first before playing around with the little bolts. And that was pretty much it for the building part of the kit. I just had to finish setting up the casing.
Chasing every starlit dream, falling in the ocean of your arms. There is nothing we can't be, even though the freedom of this love.
So here we got a power plug-in that is on currently, and we got our little voltage generator. Let's see what happens. So we're gonna plug it in. Right away it turns on. You can see that it says 125 volts right now. It's 122. Let's see what happens if I hook it up to my multimeter. And you want to go to DC volt. There you have it. Well, it's a little bit off. It says 127 on here and 122 on here. Let's see if we can go up a little bit more higher. So if I crank this just a little bit, yep, there you have it. It's going up. We'll go a little bit more, 5 volts. There's 7.9, 8, 9, 11, 12. Gets pretty bright. There you have it, 13.3 volts, and I'm right maxed out. 13.5, 13.5. I'd say it passes the test. I got this mini light bulb. So there's the light bulb. And I will turn it on for you so you can see. Oh, you're at 3 volts. Nope, that's it, 3 volts. If I give it more, it might burn out. But there you have it. Just a little light bulb. Turn it off again. There you have it, guys, it's working. And I will be also using it on my oscilloscope from my previous build, so stay tuned for that video coming out next. And also, if you want to build one of these yourself, there will be a link in the description, so make sure you follow that, and it will help my channel grow very massively, and I can make more future projects if you support my channel. Thank you very much, and stay tuned for the next one.